Today's lecture is on voltage control oscillator. Circuit towards the left shows the voltage control oscillator, which consists of two operation amplifier and with a resistor and also a MOSFET. The op-amp with a capacitor work as an integrator, and it has inverting and non-inverting terminal respectively marked as 2 and 3, which are connected to input voltage Vi. And there is also a op-amp, special kind of a op-amp LM311, which has shown with the symbol BJT inside. So to start with, we have resistance R2 and R1, which are connected to MOSFET. MOSFET is N-channel enhancement type. Now voltage at terminal 3 will be Vi into R3 upon R3 plus R3, which will be equal to Vi by 2. Now, by the principle of virtual ground, voltage at terminal 2 will also be equal to voltage at terminal 3, which is Vi by 2. So, the current I1, which is flowing through 2R, will be voltage at Va minus voltage at terminal 2 V2 upon 2R, which will be equal to Vi by 2, which will be equal to Vi minus Vi by 2 upon 2R, which will eventually be Vi by 4R. Let's discuss about the second op-amp LM311. Now it has two terminals, of course, denoted as Vn, inverting terminal, Vp, non-inverting terminal, and the output there is a connected to a resistance R1 and R2 to supply VCC. Now for this op-amp, when Vn is actually greater than Vp, voltage at inverting terminal is greater than voltage at non-inverting terminal, then this will make BJT to on. Now BJT is on, which means the output voltage now will be connected directly to the ground. So we will get V output or VO low is actually 0. Now in second case, if voltage at positive terminal Vp is greater than Vn, this will make BJT off. V now the voltage output will be equal to VOH, output high, equal to VCC into R1 upon R1 plus R2. These are the two voltage level that it will generate at the output. Output will be triangular shape, so we calling it VTR, and the output at the second op-amp will be square wave, so we are calling it VSQ. Now if the output is low on, then it will make MOSFET off. So it means the current I1 that was flowing, that we have calculated, will flow through the capacitor. So now let's draw the output waveform VSQ and V triangular and see how they will change. The VSQ will be square wave as shown here, and we will see depending upon VSQ value how the VTR will actually change. VSQ was actually 0, the MOSFET was off, so current I was flowing through capacitor and it was going towards 0. The moment the value at inverting terminal, the VN, will be lower than the VP, or as soon as it goes to 0 or little bit negative, this will make BJT turn off. So which means now the VSQ value will no longer be 0, but actually it will be V out VOH, and it will be equal to VCC R1 upon R1 plus R2. This will make transistor MOSFET on. So there will be now current flowing through resistance R. If we calculate this current, let's say if this current is I2, and if we calculate, it will be I2 equal to V2 upon R, and we know V2 was VI upon 2R. So the current I2 is actually 2 times the current I1. So there is actually additional current. One current is coming I1 from at the resistance 2R. So this additional current will come from the capacitor that are connected. It means direction of the current has changed. Now it will going in opposite direction. So which means now the VTR start going upwards, and the moment it reaches the value uh, greater than the at the non-inverting terminal, like greater than VOH, VSQ will immediately go to 0. In this way, we will generate a triangular wave at VTR, and VSQ will be as a square wave shifting between two level VOH and VOL, and the level of the uh, triangular wave will also be VOH, and lower value will be VOL. Since we know the current through capacitor can be written as I equal to C del V upon del T, and we know I equal to VI by 4R, capacitor is C, and del V will be actually VOH minus VOL upon del T will be T by 2, and this will be Vi upon 4R equal to 2 C F, because 1 upon T equal to F, VOH minus VOL. So the frequency F will be Vi upon 8 RC in bracket VOH minus VOL. So we are able to control the frequency using input voltage, and of course there are component R and C as well.